Hello! In this presentation I will show you how to perform a mixed factorial ANOVA when one factor is represented by independent samples, which is the between subjects factor, and the other one by repeated measures, which is the within subjects factor. As I have already mentioned in the presentations dedicated to the t-test and to ANOVA with repeated measures, in our database called Adolescence Behavior 4, the self-esteem and the academic self-efficacy of the adolescents were measured in 3 different moments, that is, in 3 consecutive semesters. The dependent variable of our analysis will be the self-esteem, and the objective of our analysis will be to test the effect of time and gender upon the self-esteem of adolescents. Please remember that our study is a survey, which means a cross-sectional study. This means that the term effect in this context has only a statistical meaning and not a causal one. The causal relationships can be proved only within experimental studies. So let's begin. First, I will select Analyze, General Linear Model, Repeated Measures. In this window, we have to define first the within subjects factor, which in our case is time. First, we have to name this factor. So, in the first area of this window, called within subject factor name, instead of factor 1, I will write down time. In the next area below, named number of levels, we have to introduce the number of moments when the self-esteem was measured. Because in our case it was measured in 3 consecutive semesters, I will write 3 and I will click Add. Now we have to define the variables from our model, so I will click on Define. In this new window, in the left side we have a list of all variables from our database, and in the right side we have an area called Within Subjects Variables, which in our case is time. In this area, we have to introduce in ascending order the 3 variables called self-esteem, measured in each semester. So I will introduce self-esteem 1, which was measured in the first semester, self-esteem 2, which was measured in the second semester, and self-esteem 3, which was measured in the third semester. Now, in the next area below, called Between Subjects Factors, I will introduce gender, because gender is our second factor, represented by the 2 independent samples of boys and girls. So, I will introduce here the gender variable. As you can see, there is a third area named covariates, where we can introduce those correlates of the dependent variable that might be unequally distributed among gender groups and that we want to control. This way, the mixed factorial ANOVA model becomes a mixed factorial ANCOVA model, but I will not complicate further our model. Instead, I will click on the Plots button in order to generate a comprehensive graph of our model. I will introduce time on the horizontal axis and gender as separate lines, and I will click Add and Continue. Also, from the button called Options, I will choose Descriptive Statistics, Continue, and OK. Now let's see the results. First, let's take a look at the descriptive table, which is the third table, in order to inspect the evolutions of self-esteem means. As you can see, for each moment of measurement, it seems that males have a self-esteem higher than females, with approximate 1 point. Also, if we look at the evolution of means from one semester to another, it seems that for both males and females, there is an increase in self-esteem from one semester to another. Now, let's find out if all these differences suggested by the mean values are statistically significant. And for this, let's begin with the last table, called Tests of Between Subjects Effects. As you can see, the F value corresponding to the independent effect of gender has a significance level lower than 0.05, which means that the effect of gender is statistically significant. In other words, irrespective of the semester in which self-esteem was measured, boys tend to have a higher self-esteem than girls. Now, let's inspect the effect of time. And for this, let's inspect the table called Tests of Within Subjects Effects. Here, as you can see, we have several values of the F-test, depending upon the result of the test for the sphericity assumption. As I have already explained in a previous presentation dedicated to ANOVA with repeated measures, sphericity is the condition where the variances of the differences between all pairs of measurements or levels are equal. This assumption is tested in the fourth table called Moschli's test of sphericity. As you can see, based upon the level of significance for this test, which is smaller than 0.05, for our data, the assumption of sphericity is violated, so the variances of the differences between all combinations of levels are not equal. This means that in the Within Subjects Effects table, instead of inspecting the first F value corresponding to sphericity assumed, we will have to interpret one of the other three values, which are corrected values of F, correction performed for sphericity not assumed. As you can see, all the corrected values with Greenhouse-Geyser, Huynfeld or lower bound correction indicate that there are statistically significant differences between our three measurements because the level of significance is under 0.05. So we can conclude that the self-esteem significantly increased from one semester to another. The same table includes the F-test and its level of significance for the interaction between gender and time, which, as you can see, is not statistically significant because the level of significance is higher than 0.05. And this is true for all the corrections applied to the F value for sphericity not assumed. This means that the increase of self-esteem from one semester to another is similar for both genders. Now, let's inspect the graph. First, please observe that all over the graph, the blue line, which represents the self-esteem of boys, is superior to the red line, which represents the self-esteem of girls. This is the independent effect of gender upon self-esteem. Also, please observe that ignoring the gender, there is an overall tendency for the means of self-esteem to increase from one semester to another. This is the independent effect of time. Now, let's visually analyze the interaction effect. As you can see, the increase in self-esteem for males and females is very similar, which is suggested by the similar slopes of the two lines, which are almost parallel. If the slopes would have been very different or even intersected, this would have been suggested an interaction effect, but it is not the case here. In our case, time has the same effect irrespective of the gender. So, these were the main procedures involved in performing a mixed factorial ANOVA with SPSS. See you in the next presentation, and don't forget to leave a rating and a review.